All right, go. Hi, on behalf of Team 15, we're here to present our language Zenith. My name is Arvind Anand.
My name is Rahul Manoj.
Hi, I'm Harshit Singh.
Hi, I'm Akash Vijay Sarathi.
So our language specifications is that its name is Zenith. We are using the file extension .zth. It's an imperative paradigm, and the tools we mostly used was PyCharm, VS Code, and Antler.
So I'll go ahead and talk about the features. So as you can see, there are a few features. We have the different data types. We have integer, float, double, and boolean as well. We have string as well. And we handle both identifier and numerical values in different places where we need expressions, operations, conditions, so on. The arithmetic operations that we have are addition, subtraction, multiplication, and division. We also have bracket as well. And all of this has precedence included with it. Then we have the assignment operator, as it shows equal to sign. Boolean operators are the less than equal to, greater than equal to, greater than, less than, and equal to. As along with this, we also have the not, and or as well. We also have the ternary. Syntax is given here. So in conditions, we have in brackets, we have the condition, and then we have the true false condition, which is represented here as A and B. Then we also have comments and print statements as well. Comments are given with a hash, and the print statements for us are given in bracket and double quotes, as given as display function. Then we have loops. We have three types of loops. We have the for, while, and an enhanced for loop, which is the Python version of the normal for loop. Then we have the conditional constructs, the if, else if, and else. And finally, we have two additional things. We have we have a typecasting ability. In certain, for example, if you have a situation where you have an int variable and you're giving it a equal to some 3 divided by 5, we don't want it to be a float because it is declared as an int. So we typecast it to int. And we also dynamic declarations. That just means that during declaration process, we can also give it a value, give it an expression. Here, given ternary expressions also you can give, and it will give a value to the variable. So those are the features that we have. I guess we'll go for the grammar next.
Yeah, so hi. So as you can see in the grammar, we have the start block and the end. So I'm going to talk about the block. So the block is anything like statements which are enclosed in curly braces, and it can have one or more atomic blocks. And atomic blocks comprises of command and declaration. So declaration is where they are the statements where variables are defined with specific types. So we support basic types such as integer, boolean, string, float, and double. And apart from that, we also support empty declaration as well, and ternary expressions. And so commands we have the if, while, for, and also we have the assignment expressions, which will be talked by Rahul.
Yeah, I'll go ahead with the expressions part. So in the expressions, we have the assignment part, which just simply means we have an identifier, an operator, and then you have the evaluation, which could be a numerical expression, a Boolean expression, or a ternary expression. And besides that, we do have two types of general expressions, which are the numeric expressions and the Boolean expressions. So for both Boolean and numerical expressions, there is some amount of precedence involved. So in the Boolean case, you have the or and then you have the comparison operators, and then you have a bracket as well. So with precedence consideration, you have all of these statements that consider all Boolean expressions. The comparison expression also falls under that, and that is just the greater than, less than, more than, equal to, all that stuff. Then we have the arithmetic expression, which will also be the precedence considered. So it will be addition, subtraction, then the multiplication, then the brackets, as we have talked about before during the period of the course. That's the expression part. I think, Arvind, you can go ahead with the conditional expression explanation.
Yeah, so the conditional expression is basically any Boolean expression within brackets. We support if else, if, and else. Since our grammar well, first, if expressions are basically an if with a condition expression, a block, and we can have, you can have as many else's as you want, and you can basically have an else if you want or not. So we leave it up to the user. And we have since our grammar had curly braces, we have had to adapt this to Python code, which we have done, which you'll see in the future lecture and runtime. And I think Harshit will take over for the looping statements.
Yes, so we have a standard while loop. So it will be a while followed by a conditional expression and then a block of code that we want. So it can have any block of code, as my colleague explained. We have a for enhanced. So it is like a standard for enhanced from Python. So we have a for, a variable that will be there in range and range values. So it will be the starting and the stopping values, and followed by the block of the code. So range values can be given by digits, or they can be given by variable identifiers. So we can specify n, or like whatever the value n has some. So it supports that. The for loop is a traditional for loop from C. So we have a variable identifier starting from I equal to 0 till a Boolean expression and the variable change part. So if we are increasing it by 1 or 2, so we have the minus operator as well as the plus operator, increment and decrement expressions. So we support both of them. So we also have ternary expressions. So we have a conditional expression followed by a question mark, and we can have expressions then afterwards. So we also support valid strings and Boolean types for ternary expressions. So Arvind will continue with the rest of the grammar.
I think Akash should take over for the values and print and. Never mind. So for the rest of the statements, we have the values, and the print statement is basically any print followed by any print parameter. And the specific thing in our grammar is that you can have as many print statements separated by a comma. You can have one or multiple. Also, something specific about Antler. Antler requires that all the primitive types, such as digits, are put in capitals. And we have just followed that denotation for our grammar, since we are using Antler for us.
Just to add on, those are called lecture rules, and the ones that use other rules within them are called the parser rules. So just the Antler syntax is that for lecture rules, you have it as capital. While for parser rules, it's the small.
Yeah.
So these are just a list of another whole bunch of lecture rules that we are using all across the grammar, and we've just listed it all together at the bottom. Additionally, I think we have the comment feature as well. So it's just anywhere in the code that we put our ZTH code, Zenith code, we can just put a comment starting with hash, and it will not be considered within the parser. That's what the skip does. Yeah, so that concludes the grammar part. I think we'll go ahead to the parse trees that we have generated from our grammar. It will help understand how our grammar looks. Once, give me a second. Yeah, there's a delay, sorry. There you go. So we've just listed the grammar in our presentation. And yeah, I mean, we'll just briefly mention the program flow as well. We have the input file, which we send through the command line. And we get the tokens, and then we have the parse tree. This is the part that the grammar does using Antler. Once we have the parse tree generated, then we have the listener file, which we'll also talk about later, which converts our code into intermediate code. And that intermediate code is then sent to the runtime file, which then executes it in the language of our choice, which in our case is Python, and produces the output that we need. So yeah, I just wanted to show the parse trees for some of the code executions we had. We'll get to the code later. So we have a whole bunch of code here for different cases. We have prime number here, and this is the parse tree for prime number, declaration, expression. We'll come to the code later and how it works, but these are the parse trees for all of them. So coming back to the code, I think Harshit will explain and I'll show you during his explanation and what goes on during the implementation. I think we'll start with the declarations one, right?
Okay, do we want to list
Yeah,
the
just
listeners
like-
first?
Yeah, just.
Oh,
give me-
yes, we can go to the listener first. Yeah.
Yeah.
So Harshit, maybe you can explain the listener. Yeah.
I think Arvind can start with the indentation because it's very important.
Sure.
Yeah.
Yes.
All right.
Yeah.
So for our if condition, since we did have we were kind of following C's grammar where you have curly braces, and Python does not follow that. We had to kind of have an intermediary where we basically introduce indentations into our parser.
Intermediate
So,
code. Yeah.
Intermediate code, yeah. Right. So we have two functions. It's called indent-op and indent-op condition. So basically what this function does is it maintains a list of children in the intermediate, like list of children in the
So to be specific, I would say it's a stack. So what you would have is the count. So at each stage, you would have the count of the children. So
yeah, the
as we
count of-
progress, we just keep the track of where we need to put the brackets back into our runtime code so that we can address it during runtime.
Yeah, so whenever we see a condition block, we basically push it into the stack with the number of children it has. And if a child has another condition block, we add it to the stack. And every time we execute one child, we decrement the stack's last element. And if the value is 0, we pop it, which basically means it closes an indentation, it removes an indentation, and we add to the intermediate output a closing bracket, so we are able to track it. And this allows us basically to see the length of the stack would be the level of indentation we have. And this helped us to convert brackets into like indentation. And during runtime, as you can see, we have the indent. We basically check for the indentation and then we add it. And while there's indentation, it basically makes it so that the Python can understand our code.
It
So
adds
I
the
think-
intents based on the brackets, removes the brackets, and just converts it full into our Python code. Since our runtime basically wants to evaluate using Python, it needs to be full in Python. That's the reason.
Yes, and I think another thing we have written in the listener is that we have included
Typecasting.
typecasting.
As we had
Yeah.
mentioned earlier for the int and the float part. Yeah.
So I think
Harshit, maybe you
would-
can
Yeah,
talk
I
about it.
think,
Yeah.
yeah, okay. So can you go to the top? I'll just
Yeah.
just show them how we are adding the intermediate output codes. Yeah.
Okay.
So we have a intermediate output. So what we do is every line by line, what we do is we parse it and do all the functions, whatever we want to do on it, and push it to an intermediate code. And this will be passed to the runtime file that will do all the indentation stuff and then hand it to Python to execute it. So this is how it's going on in this listener file. So like the typecasting stuff. So we can see, can you go to the integer declaration?
Yeah.
So integer assignment, yeah. So if we have declared an identifier like a as an integer, so if we are doing, if we are trying to assign it division value like 3 by 5. So it will not be an integer value anymore, right? So, but we have declared it as an integer initially, so we want to maintain its type. So what we do is we internally typecast it. So the using int here. So we are making our language type safe here. So the variables do not change the types in between. So there are no errors like that. So
Of
can you?
course, yeah, just to pinpoint in detail here, we are not actually evaluating it, I guess. It's just the string that
Yeah.
has that operation so that the runtime can then understand, okay, this needs to be typecast.
Typecasted, yeah.
Yeah.
We don't evaluate anything here. We just
Yeah.
add it to the intermediate output, and
Yeah.
then the evaluation is done by Python. So as you can see, we have many empty functions that are just passing. So what's happening here is, so the child components for those parent functions are doing the computation that is needed. So what the parent does is it just passes on, so the child can execute. Otherwise, we will have to write it in parent, and so it will be duplication of code that we don't want. So we just pass whatever we have to the child, and it does the computation, and it pushes to the intermediate output code. So this is all the evaluator logic that we have written in this in the listener file. So one such thing that I can explain is for enhanced, let's see. Yeah. So as you can see here, so what we do is we are trying to create a value like string. So we want to put it into intermediate code. So we start with for. So the syntax Python understands. We get the variable identifier from the parser. So with variable identifier.getText, we add in range because that is the Python syntax for the for enhancing, and then we enter the range val. So we get the range value parameters from the parser, and we insert it here and pass it and add this block to the intermediate output in line 641, and we just push it. So this is how our functions are working.
You can see here that this is what it looks like in the intermediate code.
Yeah.
For this particular thing.
So everything else is handled at runtime. So I think Rahul can explain how we are handling the intermediate output block that was sent.
Yeah. So once we have gotten to the runtime, now we have two things to notice here. We do have generally the Python code now, because what our interpreter, it is in Python, right? So we need to have all of the code written in Python, but we also have the brackets, and these brackets are for capturing the indentation. So the intermediate code has the Python code plus the brackets. Now here, before we actually evaluate or the Python actually executes this code, we will just simply remove these brackets and add the indentation. So earlier Aravind had explained this, so I won't go into it again. But an additional thing we have to explain here is what we are doing for a whole block of code. So there are a few different places where we have whole blocks of code. That's in if and for and while. So in these sections, we basically track where the block starts and ends, and then combine the entire code together. So that Python understands, okay, there's an if and an else, they need to go together and they need to be executed together. It cannot be executed line by line. Like for example, a print statement. A print statement could be executed line by line because it does not depend on the previous or the statement after. But a for or an if cannot be. So it has to be executed together. So that's why this part executes. So we have two exec functions here. So this will be for the combined code, and this is just for single line executions. So that's basically what the runtime file does. It just executes all kinds of intermediate code. So that completes the code explanation. I think we can go to the sample runs at this point, right? So first we'll go to the declaration part. So we have our command as Python, the file, and whichever file we need to execute. So in this case, since we are starting with declarations, it's the declaration. So Harshit, maybe you can explain.
Okay, I'll start with the declarations file. So as you can see from the top, we have a start and end block. So we have integer a equal to 5, integer b, we have not given any default value. So that the thing that you're saying is a comment, default value equal to 0. So our language should actually make the value of b as 0. Boolean C default value is true. We are not explicitly providing any default value for C. For string, we have the Zenith grammar. For float, we have provided it a 3.55 value, decimal value, and for double, we have also provided it. So as you can see in the bottom, the values after, so the intermediate, you can see the intermediate code here and the values after execution. So A is 5, A remains 5 because we assigned it. B becomes 0 because the default value for any uninitialized variable in our language is 0. C becomes true because for any Boolean variable, the default value is true. So you can see there. Zenith grammar, the string, our string was Zenith grammar. And for float, we have kept the precision as 4. So you can see three characters after the decimal point. And for double, there is no precision set. So double can have any number of decimal points after that.
There's no specific reason to pick 4. It's just to show that we can manipulate our precision as we wish.
As we
So,
wish, because
yeah.
Python can handle it, but we wanted to make something on top of it. So for float, we have kept the precision as 3, 4.
Yeah. Also, this default value thing is also something that we added so that a person who uses our language knows, okay, it is 0 at the beginning and it's not some ambiguous garbage value.
And if you look, we have included comments. So the comments are not written even to our intermediate code. So
Correct.
the entire default value equal to 0 and default value equal to our comments, and it has not been written either in our intermediate code or in our final output.
Yeah.
I guess we'll go straight to the expressions next.
Yeah. So can
As
you
you can
open
see,
the
yeah, I'll
expressions
open
file?
it. Yeah.
Okay, so we have given declared int a and boolean b. So from the previous example, we know the value for a will be 0 and for b it will be true. So now we are assigning the reassigning the values here. So like b becomes true or b. So true or b was true, so it will be true with an and, then b and true, so it will be true, true. So this is how like we have taken care of our expression. So it will evaluate it. And similarly for a, so we have taken care of precision. So like the brackets are evaluated first, then the multiplication and division operations, and then the subtraction and addition operation. So after evaluating, we are doing a print statement. So separated by a comma. So we can see like we can have as many prints as we want separated by comma. So these are we are passing the values, the variables to it. So a and b. So as you can see at the bottom, so we get the value for a as -23 and b as false after evaluation. So at the end, you can also see that values after execution for a and b are a is -23 and b is false. So
This is the representation of our environment.
yeah, this is
basically.
how environment. Yeah.
So I think we'll go on to the next one then, which would be for, right? Or
Ternary.
ternary. Okay.
Ternary works, yeah. So these IZTH files that you are seeing, they are actually
Intermediate. Yeah. They're the generated intermediate code.
Yeah, these are the generated intermediate code files. So yeah, so this is the ternary assignment while declaration. So we have this feature that while declaring any variable, we can have a ternary expression, evaluate, and then assign the value to it. So here we can see, so we have given the example for strings and integers here. So if 2 greater than 1, that evaluates to true. So a should get the value 5. And for string, 100 is less than 231, so it is also true. So it should get the value of allowed. So as you can see after at the bottom, a takes the value 5 and s is allowed. So Rahul, can you switch the conditions? Just add a greater than symbol. So we can show that it's not static value because both were true. Yeah, so here he switched the string one. So it's 100 greater than 231, that evaluates to false. So it's denied. So we can see S becomes denied here.
Okay,
Alright.
so now we'll go towards the loops. We will start with for enhanced, I assume, right?
Yeah.
We'll start with for, I guess. So this is a simple for loop. Harshit, you can explain.
Okay, I'll go with the for loop. So int C, the default value is it gets is 0. So inside the for loop, we make the C as 1, start from 1 and till 10. So it should be printing like 9 times hello. So inside the for loop, so we can go ahead and count. So this should be 9 times because it is running like 9 times here. So this is how a traditional for loop in C works. So it's the same thing. So it does not go up to the upper limit. And so we get hello in our console like 9 times. So this is pretty standard for loop. I think we can go ahead.
For
For
enhanced.
enhanced.
What,
Not
sorry.
not the IZ.
Yeah.
Intermediate.
Arvind, do you want to take this?
Yeah, sure.
Yeah.
So for enhanced, it's similar to the for loop in Python. We have count. Anything which we've not declared as a value is it's 0. So for I is equal I in range of 2 is to n. So you have d equal to n divided by I. So it's 36 divided by the 36 divided by the I value of that range. And we have like an if condition, and we're basically incrementing count, and if count is 0 we print prime, or else we're printing non-prime. So this is a simple for enhanced looping statements we've done, I think.
Yeah. And we have the same execution in for also. The prime executed in for enhanced, and we have it for not for, I think, while, right?
No, it's
Yeah.
for
We have
prime numbers.
prime numbers.
Prime numbers.
We have
Oh, in prime numbers, yes.
Yeah,
we have a prime
program
numbers.
called prime numbers.
Yeah, which
We have-
executes a normal for. Yeah. So
Yeah,
this
so-
is also the same thing. Yeah, but we'll come back to it.
Yeah.
This is finally the while.
Yeah, this is bog standard while loop from a is greater than 0, and then we decrement a from 10 to 1, and then if you can see in the environment, b is being incremented 1 continuously. Since it started with 1 and it's looping 10 times, the final answer is 11. So I think it's a quite simple while loop. I think that's all for our basic functionality. So we have 2 programs. We've done a factorial and prime numbers. I think for the factorial, it's quite simple. We just use a for loop to find our factorial. You put, I think if you put 7. Yeah, if you put 7, we get the output as 5040, which is the factorial of 7.
Yeah. And
And
if you change it to, let's say, 8.
Yes, you'll get
Then I
something
run it.
much bigger.
A little bit bigger, yeah.
Yeah,
40320.
And prime numbers we already showed you, it was the same as
Yeah,
for
same thing
enhanced
as-
example, except instead of using the for enhanced, we use the for loop to check if it's a prime or not.
One
Yeah.
thing I'll mention here for the feature for our language. So here you can see D is initialized. The type for D is int, right? And inside the for loop, we are doing D equal to n by I. So at some point in time, it gets like divided by something that's not its fact, and that's not its factor. So it becomes a decimal number, but we don't want that. So our language is taking care of it. So it is ensuring
Type
that D is always int at all points. So this is how we're doing the.
Did we cover nested if?
Oh yeah,
No.
we should show nested if as well. Yes.
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 Down.
Yeah. So we
Yeah.
have a very complicated if statement. So this just shows the strength of our if nesting, I guess. So I'll just run it and show you what the result looks like.
It shows how well we indented it.
Yeah. So let's check which case it is here. Yeah, so we have commented out this particular line. I'll come back to this. So the computation of this particular entire thing is 207. So it basically goes inside this function, sorry, inside this if, sets the value of A to 51, I think, because A we have made 513 comes inside here, comes to 51. And then because it's inside this condition, it puts C equal to 10 inside this one, that is. And then because of that, we don't execute any of the other things, leaving A as 51 and C as 10. And all of these were set earlier. So as you can see, it executes, comes inside this if condition, executes it thoroughly, and doesn't go inside like other if conditions, that else if and else conditions that it's not supposed to. Now, if I was to simply say, okay, A is no longer 207, I will first make it A plus 4 because we have an else if case for that. So if I run that, you'll see that C has become 111. This is because A has now become 211. So that it goes into this condition, C becomes 111. And again, if I make it A equal to A plus 10, now it goes into the else condition, which makes it C is 119. So that thoroughly shows all three cases running. And yeah, so that's the completion of the if nested if running execution. And that completes all of our normal executions and the code explanation, as well as the explanations for our structure of the project that we did. Thank you.
Thank you.
Thank you.
Thank you.